and today's topic is given to me trigonometric functions. You know some idea of functions? Understand what is a function is? I leave for you to decide that what a function is. But this trigonometry has gone a lot of changes. So whatever material has been provided to you, that speaks of S.L. Loney's book. And S.L. Loney's book we were reading as a student. And about how many years can you guess? About 60 years back when I was a student. So I was reading S.L. Loney's book, and that was still written 30 years before that. So about 100 years back, and still that material is smelling, gives you the smell of S.L. Loney's book. But this trigonometry has gone a lot of change. Now NCERT has put a perfect, you can say, concept to this trigonometry. So now these days trigonometry is not being taken as just binding in that triangle. We are not remained binding in that right angle triangle. Now this right angle triangle in class 9 and 10, we know about this type of triangle, OMP, a right angle triangle. We mark this angle as theta, then we define sine theta, cos theta and all that. That was limited only to a triangle. Of course, we are to solve some problems on triangle as well. Then we might need this type of trigonometry. But we are to go much beyond that. We are to go in calculus. We need the trigonometry for calculus. We need the trigonometric functions for physics. Many things. We are to go much beyond. And trigonometry has gone a sea change. So we are not to think only about that triangle. We are to think much beyond that. Much beyond that. So today I am trying to, first of all, give you a proper concept of the trigonometric functions. Then, of course, I will take up the questions. Concepts are very much needed. The problem with our teaching is the concepts are not given. Just the students are given a list of formulas, and then they are asked to go through the problems. So, but still, some concepts are basic, fundamentals. So concepts must be known to us. So if I mark a type of a circle like this, I am marking a circle here. So here is the initial line, and you can call this angle, say this length of the arc. I call this length of the arc, say as L, this as R. I call this angle as theta. I think you are aware of this type of result, L is equal to R into theta. You have read this result? L is equal to R into theta. Or can I write it like this? Theta is equal to L by R. Theta can be written as L by R. Now my question is, what is the theta? What is theta? What do you think about theta? What is theta? Theta is an angle. What do you think? Angle. So here is the problem. This is the real problem. The people don't understand what is the theta. I go to many workshops, even in teachers training programs. So again, I find some problem with the theta. They don't understand properly what is theta. Look here, this L is a length, say 4 centimeter. This is, say, radius, 3 centimeter. So 4 centimeter by 3 centimeter. So what is this ratio? 4 centimeter is to 3 centimeter. 4 centimeter is to 3 centimeter. If I ask you what is this, will our answer not be 4 by 3? 4 by 3. And 4 by 3 is a real number. 4 by 3 is a real number. So L by R is a real number. L by R is a real number. So that means theta is a real number. Theta is a real number. Don't think about an angle. It is a number. It's a real number. So theta is that situation. Quite clearly speaking of, it is L by R. And L is a length, R is also a length. So this length ratio, 4 centimeter is to 3 centimeter. Ratio is 4 by 3. That means theta is a real number. So we should think properly, not an angle. It is a real number. So that type of situation. And in particular, if I make the radius as 1 unit, if I make a special case, that radius is equal to 1 unit, then this theta will be equal to r. In that particular situation, if I make the radius as 1 unit, so in that particular situation, theta will be equal to L. So this length of arc and this real number, this real number, this real number, then of course they will turn out to be equal. So that is the type of situation. Now, Dr. David Cohen writes in his book that trigonometry, you have imprisoned the trigonometry in a right angle triangle. Imprisoned, using this word imprisoned. You have imprisoned the trigonometry in a right angle triangle, whereas it is a free bird and moving along the globe. It is a free bird and moving along the globe. Now let us see that why he is writing like this, that it is moving along the globe. So this trigonometry is not limited to triangle. So this trigonometry must go on moving and moving along the globe. Globe means moving along the circle. It must move along the circle. So another name for the trigonometric function is the circular functions. Circular functions, how we can connect these with the circular functions? Let us try to connect it with the circular functions, the real shape of the trigonometry. So we want to see what is the present shape of the trigonometry. You know that all real numbers can be represented on a line. Here is the real axis, origin, say 1 unit, 2 unit, 3 unit, minus 1 unit, like this. So every real number can be represented by the points on the line. Corresponding to every real number, we'll be getting a point on the line, and corresponding to every point on the line, we'll be getting a real number. Is it right? Now, can you represent these real numbers on a circle? The question is this. Can you represent these real numbers on a circle? Have you imagined that real numbers? So you have learned trigonometry without any concept. Concepts are not with you, and you have learned the trigonometry. So that is what is happening. So see the situation. Now here is, I mark a circle and of radius 1 unit. Whatever is this unit, you select this unit. This may be taken as 2.5 centimeter. Whatever it is, you take this as 1 unit. You take as 1 unit, and then you will mark 2, 3 like this, -1, -2, and so on. 1 unit. So exactly same as radius. I am taking as radius, this much as radius. Here is a circle. So I am taking this x-axis. So here is the y-axis, x-axis, y-axis. Here is the origin. So this is y-axis, y dash, x dash, and all that. What will be the coordinates of this point? Can you tell me the coordinates of this point? This is 1 unit. The radius is 1 unit. So what will be the coordinates of a point? 1, 0. No problem in it. The coordinates of this point should be 1, 0. What should be the coordinates of this point? 0, 1, right? 0, 1, 0, 1. And then what will be the coordinates of this point? -1, 0. The coordinates of this point, 0, -1. I think there is no problem. This radius we have taken as 1 unit. So we can take the coordinates of these points as 0, 1. This is 1, 0, 0, 1, and all that. This type of situation. And what can you think about the circumference? What will be the circumference? 2 pi r. And r is 1 unit. R is 1 unit. So that means in this situation, the length of the circumference, that becomes 2 pi. The length of the circumference becomes 2 pi. And now here is your imagination. This is how it works. Can you imagine that you are pulling this line out? You are pulling this real axis out. Imagine that you are pulling this real axis out and turn it through 90 degrees. I think we can imagine that. We can turn it through 90 degrees and match this point with this point. You are matching this point with this point. So here is your real axis. Real axis that stands like this. So here is the real axis. Is it right? I am just imagining that pulling that line, turning this through an angle of 90 degrees, and matching this point at this place. Matching this origin here at this place. Is it right? And now a little more imagination. You wrap this line along the circle. Wrap this line along the circle. Can you imagine it? You are wrapping this along the circle. It has got no thickness. No thickness. Don't think that this will thicken, your reel will thicken. There is nothing like this. It has got no thickness. Just imagination. 1 rap, 2 rap, 3 rap, whatever may be the length. It's quite a big length. So you just go on wrapping. Is it right? So are you not getting that corresponding to everything? We'll be getting a point on the circle. Corresponding to every point here, we'll be getting a point on the circle. Is it right? And this portion, you can wrap like this. This portion we were wrapping in this way, anti-clockwise, and this portion you are wrapping like clockwise. So your whole number line has been put on that circle. Whole number line has been put on that circle. That means every real number, corresponding to every real number, we are getting a point on the circle. Is it right? Corresponding to every real number, we are getting a point on the circle. So I can take any real number, say real number x. So here is a point, and that point represents the real number x. I'm taking a real number x. So corresponding to this thing, can we get a point on the circle? I think here is the origin, that origin is matched here, and we'll be getting a point. So somewhere we'll be getting a point. Maybe here, if this is more, greater than pi by 2, we'll be getting a point here. You'll reach pi by 2 at this place, because the total length is, total circumference is 2 pi. We have started from here. So this pi by 2, pi, 3 pi by 2, 2 pi. And if it is more, we'll go on taking rounds. And if it is negative, then we'll move like this. So one thing is quite clear, that corresponding to every real number, so we are getting a point on the circle. Is it right? So do you agree that corresponding to that point? So here is the real number x. And what is really x? That will be this length. X will be this length. Is it right? This was this length. X was this length, and here is this length x. So this is the AP that will represent x length, x real number. AP will represent x. What will be the coordinates of this point P? Any coordinates? Say as alpha, beta. Let me name those coordinates as alpha, beta. So here we are working in that plane, in a plane. So we have got x-axis, y-axis. So we must be getting the coordinates of that point. Is it right? So here I am defining circular function of a real number. I am not defining the ratio. Not like this. We are much above that ratio. Leave that triangle. You are now moving along the globe. So see the situation. So what is your sine of x? What is your cos of x? Sine of x is being taken as this y coordinate. And here is your cos of x. That is the x coordinate. So these are the definitions of circular functions. Trigonometry altogether put in a different manner. This is what your NCERT book is speaking. And nobody is teaching it in a proper manner. They are just thinking that what it is and where the trigonometry has gone. Trigonometry is moving along the circle. Trigonometry is moving along the circle. So we have defined sine x and cos x. If anybody says, what is the domain of sine x? If anybody says, what is the domain of sine x? What you have read in your classes? Oh, no, domain, that is, you are talking about the range. Domain, all reals. So why you have said that it was all real? When you are thinking about that it is in terms of ratio, so there was no logic behind it. You might have just crammed, and the situation was not clear to you. And now it's very clear to us. When we say, what is the value of x? Values of x, that forms the domain. Values of after range, that will come later. Is it right? So x, that is why we were saying that the domain of this sine x is all reals. X is any real number. X is any real number. So without knowing anything, you are saying that the domain was real numbers, without realizing what it is. So I think you have realized that what it is. What is the real situation? So real situation is like this. So here we have defined sine x, cos x. These are the only two basic trigonometric functions or circular functions. You can call them as trigonometric functions, or you can call them as the circular functions. Now here we know what x is. X is a real number. X is a real number. That is why we can say that the domain is all real numbers. Is it right? And then this tangent, cotangent, there should be no problem. So this tangent is sin x by cos x and all that. The things are so simple. So not much burden. The only problem was there to think about what is the sin x, what is cos x. Just very simple. We have got the coordinates. X coordinate, we call it as cos x. And the y coordinate, we call it as sin x. Simple. Cos x, sin x. So this x coordinate, we are calling it as cos x. Y coordinate, we are calling as sin of x. That is the type of situation. And now here you can think about the range. So range means what? What is the range? The values of beta. The range means the values of beta. Is it right? What can be beta? Look upon the figure. What can be the value of beta? Beta means y coordinate. And y coordinates, it is just moving on the circle. Just moving along the circle. So your beta can be this or this maximum. Otherwise, beta may be here, 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 anywhere. So this may be beta, this may be beta anywhere. So this is the maximum, -1 to 1. -1 to 1. Beta is -1 to 1. See how the things become so clear. That is the range. Range is -1 to -1. -1 to 1. So what is your cos? What is the range for the cos? Range for cos is your alpha. What are the maximum values of alpha? Alpha is varying only on the x-axis. So here is -1, this is 1. So domain and range, they are speaking like this. So not much burden on the brain. So what is your sign of 0? Where is 0 real number? 0 real number is at this place. Is it right? Sin 0 is 0 and cos 0 is 1. Is it right? Sin 0 is 0, cos 0 is 1. What is sine of pi by 2? When you are calling pi by 2, that means you are at this place. Is it right? So what is sine of pi by 2? 1. What is cos of pi by 2? Is 0. Is it right? What is sine of pi? 0. What is cos of pi? -1. It is speaking. Let your trigonometric function speak. Let your trigonometry speak. Don't cram it. Let it speak. So here is your cos of pi by 2, and cos of 3 pi by 2. Cos of 3, when I am talking about 3 pi by 2, so you are here at this place, 3 pi by 2. So here is your cos of 3 pi by 2, sine of 3 pi by 2, -1. So this is how the things are happening. And moreover, you can notice, we can take a round. You are here. So if you take one more round, what does it mean? We'll be getting 2 pi plus x. So does it mean that sine of 2 pi plus x will be equal to sine of x itself? And so here you are at this place. You are at this place. Now you take one round. You have taken one round. So that means this point gives you what real number? 2 pi plus x. And 2 pi plus x, again the same thing, beta. So it has really proved that sine of 2 pi plus x is equal to, this is sine of x. Is it right? It is equal to not x, equal to sine x. It is equal to sine of x. That was beta. So we can take 4 pi plus x, 4 pi plus x, 6 pi plus x, and so on. So in general, I can say sine of 2n pi plus x, 2n pi plus x, that will be equal to sine of x, where n is any natural number. N is any natural number. So there is no burden on the brain. Just looking upon the situation, the answers, they are coming. What about cos of 2n pi plus x? What will be cos of 2 pi plus x? 2 pi plus x. So that will be again your this coordinate. So cos of 4 pi plus x and so on. So in general, we can say cos of 2n pi plus x will be equal to cos of x. And from here, we are getting periodicity, that period functions. We will be getting the situations like this. So in this way, we are getting our trigonometric functions. So what about tangent of x? What is tangent of x? How you are thinking about tangent of x? Tangent of x, we are thinking as sine x by cos x. And this is not defined when this cos x is 0. When this denominator is 0, so this is not defined. So when this cos x will be 0, can you look upon the figure? When your cos x will be 0, look upon the figure and then realize it. No cramming, absolutely no cramming. Looking upon the figure, Realization should come. So when you are at this place, pi by 2, or it is 3 pi by 2, 5 pi by 2, 7 pi by 2, or otherwise minus pi by 2, minus 3 pi by 2 like this. That means an odd multiple of pi by 2. When it is an odd multiple of pi by 2, tangent x is not defined. That is why we say that the domain of tangent x is equal to all real numbers except odd multiples of pi by 2. Are you getting the situations? So this is how the things are happening. So not cramming. We are not cramming at all. We are learning. I told you we are all learning mathematics. I am also learning. Well, you are also learning. So see the real situations. So when the situation comes clear before us, so after all basics, they must be known to us. If the basics are not known, if we don't know what are these trigonometric functions, then what we are doing? We are not doing anything at all. We are just living in air, not on the ground realities. So that type of situation is coming up. So again, I could think about cotangent of x. So what is cotangent of x? Is it cos x by sin x? Cos x by sine of x. So when it should not be defined, when this should not be 0, sine should not be 0. And when it will be 0, sine is 0 either at this place or at this place. That means at 0 or pi, 2 pi, 3 pi, 4 pi. Is it right? So that means this should not be equal to n pi. N pi. So cotangent is what is the domain of the cotangent? Domain of your cotangent function is all real numbers except what? N pi. Where of course n is a natural number, or n is any integer, not natural number. Any integer, positive, negative, anything, leaving out that. So accept these n pi. So that is the type of situation. Is it right? The same thing situation can be made about secant, cosecant. And then what about the coordinates of this point? 0, 0. Am I right? And you know the coordinates of this point, alpha, beta. What is this distance OP? What is the distance OP? 1 unit. You have agreed that this distance is equal to 1 unit. Or can I say it OP square is equal to 1? 1 square is 1. Can you write the distance between these 2 points? Distance formula you are aware of. So what is that? Alpha minus 0 whole square, beta minus 0 whole square. Are we not getting like this? This implies alpha square plus beta square is equal to 0, 1. Alpha square plus beta square is equal to 1. So what does it mean? I think you have proved that cos square x plus sine square x is equal to 1. So how the things are happening? So things are happening so beautifully, so nicely, provided we understand. The meaning is to understand. So we not much burden on the brain. And here we have proved such a result for all real numbers, not only in that triangle. We are free from triangle, and we are really moving around the globe. Why can't we take the radius of the earth as 1 unit? You can imagine the radius of the earth as 1 unit. And here is your trigonometry. Trigonometry is moving along the globe. So that's why Dr. David Quinn is saying that this is a free bird and it is moving along the globe. And these days, this is the shape of the trigonometry. You are living in 21st century, and 15 years have passed still, and you are going 100 years back. So it is not that trigonometry. It is the trigonometry, this trigonometry. This is what we need in our calculus. This is what we need in our physics, in our higher mathematics. This is what is our requirement. Should I give you 1 or 2 more formulas and just their proofs, and then I will be coming to the questions. So main concern, of course, in IIT, that is about the questions, but I like to explain a little bit, some idea that what is the real shape of the trigonometry. What are these circular functions? So I want to explain these type of results. Sine of minus x is equal to minus sine of x, and cos of minus x is equal to cos of x. I think you are aware of such results. And then about tangent, cotangent, you can write it directly. And there is no trouble. When you want to write tangent of minus x, write it as sine of minus x over cos of minus x. And if these results are known, then everything will be fine. Now, how to get their proof? We are working for all real numbers. So x belongs to R for all real numbers. I am not remaining in that triangle. We are not limited to triangle. We are working on all real numbers. So how to bring out for all real numbers? So here is your unit circle. Here is unit circle. These are the x-axis, y-axis, x-axis, y-axis. This is the origin. So y-axis is this place. This point, we know its coordinates are 1, 0. That much is known. Anyway, so that type of situation. So here you mark x. Somewhere, it is all up to your will. You may mark this x here. You may mark here. You may mark at this place. I have no problem. I can mark x anywhere. Even my x may be negative. I can start marking like this. Anywhere I am marking x. X I am marking somewhere here. So what about the coordinates of this point? What will be the coordinates of this point? Alpha, beta. What is alpha? Cos x. What was beta? Should we save one step? You are intelligent enough. I think we can save one step. Instead of saying alpha and beta, what is the role of alpha and beta? There is not much role. We can directly say the coordinates are cos x and sine of x. What's the problem? Alpha, we were calling alpha as cos x, and beta, we were calling as sine x. We can save one step. We can directly say the coordinates are cos x and sine x. No problem. Is it right? And then this was x. X was this number. That was x. X was really this number. Now here is your minus x. Somewhere here I am marking minus. So this is your minus x. What about the coordinates of Q point? In place of x, we have got minus x. So what about the coordinates of Q point? Can I write cos of minus x and sine of minus x? Here are the coordinates of this point. Because that number was x, we are writing the coordinates in this way. And here, this number is minus x. So we are writing the coordinates as cos of minus x, sine of, this is cos of minus x, sine of minus x. Is it right? Now, what I am planning is, I am just joining these two. I am not drawing any perpendicular, nothing of the sort. Nothing is known to me. I am just joining these points. I am naming this point as M point. Well, I am joining O and P. I am joining O and Q. Are these two triangles congruent? I am thinking about triangle OMP and then triangle OMQ. Are these two triangles congruent? Why? Yes? If it is wrong, then we are learning. There is absolutely no problem. There should be no burden on the brain. If we commit a mistake, that is a place from where we are learning. I am of this attitude. So committing mistakes, we are learning. Yes? You are saying that one thing, let me say, OP is equal to OQ. Is it right? Radius, OP is radius, OQ is radius. And OM is OM common. OM is common. Then what else? Tell me the third thing. Two things I have written. OP equal to OQ being radius. OM is common. Then what else? Yes, what else? Yes? You will say that MP is equal to MQ. That I do not know. Right angle, I do not know. I have just joined. I do not know whether it is a right angle or not. Really, I want to make it a right angle. I want to prove it that it is a right angle. I want to prove it that MP is equal to MQ. I want to prove it. What else? No. Look here. This length and this length, they are equal. Look upon the situation. This length of the arc and this length of the arc, they are equal. And in 10th class, you must have read that equal arcs, they subtend equal angles at the center. Equal arcs, they subtend equal angle at the center. Is it right? So they subtend equal angle. This arc AP is equal to arc AQ. So they subtend equal angles. So that means angle, this MOP is equal to angle MOQ. So I have given the reason for that. That angle MOP is Y angle MOQ. So these angles are equal. The reason, picking up from here, these are the lengths of the arcs. They are equal. And now the triangles are congruent. So two sides are equal. Included angles are equal. Included angles are equal. That is why the triangles are congruent. And if the triangles are congruent, this side must be equal to this side. Is it right? This angle must be equal to this angle. And now it is a straight line. The sum of both angles is equal to 180. And these angles are equal. So now you can say that each angle is equal to 90 degrees. And if each angle is equal to 90 degrees, so this becomes y coordinate. This becomes x coordinate. Is it right? So this becomes y coordinate, this is x coordinate. X coordinate of this point, x point, coordinates of this point equal. OM is x coordinate of this point. OM is x coordinate of this point. Is it right? So it has proved that cos of x is equal to cos of minus x. Is it right? And then here you find that this MP and this MQ, in magnitude they are equal, but in sign they are opposite. One is here, the other is in the fourth quadrant. So that means MP is equal to minus MQ. Is it right? So it has proved that sine of minus x is equal to minus sine of x. And it has proved cos of minus x is equal to cos of x. Is it right? So this is the real trigonometry. So should I go through one more result, or just going through the questions? What you want? I will go according to that. So one more result I want to bring out so that you may be somewhat clear that how these formulas are framed. I am not thinking that you are just go on cramming. So some reason behind that. I think in our schools there is a little bit problem. Nobody is teaching the trigonometry in the proper shape. NCERT book is quite clear. Now, whatever I am writing, this all concepts are being taken from NCERT book. So another result which I want to bring out is cos of x plus y is equal to cos of x cos of y. And what is the result? Sin x sin y. I think you know the formulae. Cos of x plus y is equal to cos x cos y sin x sin y. And this material provided to you in Udan, they are still talking about x and y are angles. I think they are living 1 century back. They are just speaking of S.R. Loney's book, whereas these are real numbers. We are moving around the circles. So x and y are real numbers. If they are real numbers, it is well. And moreover, one thing more I have forgotten to clear. So that was a type of situation. This was a circle. And if this length was x, this length of the arc, if that was x, and what about this angle? That was the radian Mayer. This was also a real number. So it is the radian Mayer, not say in degrees like that. Radian Mayer. What is the radian Mayer is also x. So if this length is x, well, what is the radian Mayer of this angle? Radian Mayer of this angle is also x. So well, here we get an advantage. If you have learned the trigonometry here at this place, so you can still interpret it in the form of angles, but only in the shape of radian Mayers. So their radian Mayers are known. Now, if I say, what is the cost of, say, this marker, rupees 10. So if I put the question like this, so what is the cost of this marker? What should be your answer? Rupees 10. Is it right? Answer should be rupees 10. And if I put the question like this, in how many rupees you have bought? In how many rupees you have bought this marker? What should be the answer? 10, not a 10 rupees. My question is like this. In how many rupees you have purchased this? 10. In how many rupees Here you don't put unnecessarily 10 on its head. So my question is like that. So here my question is like that. What is the radian Mayer? What is the radian Mayer? So radian Mayer, you give the radian Mayer, whether it is 2, 1.5, whether it is pi by 3 or whatever it is. Pi by 3 is a real number. You understand? Pi by 2, whatever it is. So answer should be put in that form. That means x and y should be taken in the form of radian Mayers. So this x and y, if you want to talk in terms of angle, so that means it should be taken in the form of radian Mayers in that form. So advantage is with us. We work on the circular functions, and if somehow or other we want to go inside, well, we can interpret it in terms of angles, and that only in radian Mayer. Radian Mayer. You can put the situation like this. Can you get the proof of this? So here is the proof of this result. So I am marking a circle of radius 1 unit. Radius 1 unit. So this is the origin, this is your x-axis, this is the y-axis. The coordinates of this point is 1, 0. Is it right? Let me mark x. X I am marking a real number somewhere here. This x. What about the coordinates of this point? Cos x and sin x. Is it right? Can I write directly the coordinates of this point as cos of x and sin of x? The coordinates of this point I am writing like this. And then I am going y hat. Y I am going hat. So here is a point Q. So what is this length in total from here to here? X plus y. Is it right? So okay, what about the coordinates of Q point? Coordinates of Q point. This length is x. This length is y. So coordinates of Q point, that should be cos of x plus y and sine of x plus y. Is it right? Any burden on the brain? Clear situation? So coordinates of Q point will be cos of x plus y and sine of x plus y. Is it right? So that is a type of situation. And then I mark minus y on this side. Minus y. Whatever is this. Y minus y, exactly measured. Whatever is y length. So exactly that much length. So you can name this point, say, as Q dash, P dash. It's all up to your will. You can name this point anything. So what about the coordinates of Q dash point? Cos of minus y. This is minus y of minus y. Is it right? So here are the coordinates of this point. The coordinates of this point are cos of minus y and sine of minus y. Is it right? This is minus y. So we can write the coordinates as cos of minus y, sine of minus y. Can I save one step? What is cos of minus y? Cos y. I am saving one step. So I am writing Q dash as cos of y, and what is sine of minus sine of y, right? I have saved one step. There is no problem. Quite clear? Then what I am planning is I am joining this P and Q, Q dash. P and Q dash are being joined. A and Q are being joined. A and Q are being joined, and P and Q dash are being joined. Is it right? So is this length AQ? AQ is equal to PQ dash. AQ is equal to PQ dash. Can you give me the reason? AQ chord, that distance, is equal to PQ dash. So what is this? X plus y. Is it right? Arc, length of arc, x plus y. What is this? X plus y. Length, I am talking about length. So in total length will be x plus y. And you know that equal arcs, they cut equal chords. They subtend equal angles, and from there the chords are also equal. So in class 10 geometry, we have certainly read it, that the equal arcs, they cut equal chords. So that is the result which I am using. Using geometry of class 10, equal arcs, they cut equal chords. So these chords are equal. AP, AQ is equal to this much. Or can I say this AQ square is equal to PQ dash square? There is no problem writing square. Now, can you write AQ? You know the coordinates? Distance formula. The coordinates of A and Q are known to you. Is it right? You know the distance formula? X2 minus X1 whole square, Y2 minus 1, Y1 whole square. And then on the other side, you can write the coordinates. You can write the distance formula. So one step I am leaving for you to work at home. This AQ square, there is no need of writing under root because I have already squared both sides. So one step I have saved. So we can write this is a AQ square, and then on the other side, this PQ dash. Please do it at home. You are to learn it, not leave here. If you leave the situations in between, you are not learning. Learning means doing some labor as well. So we have to do some labor, do it, and in the process, you might have to use sine square x plus cos square x equal to 1, or sine square y plus cos square y equal to 1. These are the results which you will be required to use. Sine square x plus cos square x is equal to 1. Sine square y plus cos square y equal to 1. And finally, you will reach that result. So one step, I am saving 5-10 minutes instead of going through this calculation work. So to take you ahead. But here it has given you something. Now, supposing it is x minus y, then if it is x minus y, what I would like to do? So here was the situation, x or minus y. I don't want to put any burden on the brain of the students. I would like to put the situation like this. I put the situation just in a simple manner, x minus y. Now you know this formula? This formula is known. Apply it. And you will be getting this cos of minus y. You will be getting sine of minus y. The results are also known. So this will be automatically come out. So no burden on the brain. So such are the results which they will be coming. And moreover, so what about this cos of pi by 2 plus x, etc.? So no cramming, absolutely no cramming. So apply this formula. Apply this formula, cos of x plus y, apply that. So you will be using cos of pi by 2, sine of pi by 2, which you know. So result will come automatically. So results are very simple. So don't try to cram them, try to learn them. So better is to learn them instead of cramming them. Am I right? Learning is far better than cramming. So if your bases are strong enough, then definitely you are moving up. So here I come to the questions now. So there were first 2 pages. They were on the formulas. Please depict these 2 pages, page 1 and 2. So they were the formulas. Here I defined cos x, sin x with the help of that circle. Alpha and beta, I took the coordinates of alpha and beta, unit circle, I defined cos x and sin x. Then here I am talking domain and range. That is why we are calling domain. Domain is all real number. There is a reason now. Don't cramming, no cramming at all. We know what is the range. All these situations, they are known to us. Then sine of 2n pi plus x, I cleared it. Why it is so? So we know their domain range. So here are the, please move it. The next page. Or go on moving. So all these results are known. And here are the identities. Sine x into cosecant x is equal to 1. I think very simple. So such results, then sine square x plus cos square x is equal to 1. They're all clear now. So then here is sine of x plus y. I have proved this cos of x plus y. I especially proved this cos of x plus y. With the help of this, we can prove this. And then this cos can be converted in terms of sine. Pi by 2, we can include pi by 2. We can go through these results. So please move up. So all these results, they are available to us. There is no problem. Then 2 sine x cos y is equal to, all such results are known. This is very simple. You can write the formula for sine x plus y. You can write the formula for sine of x minus y and add up all these results. So don't try to cram only. Try to think the situation. So that is how these results are. Am I clear how I am to write? Sine of x plus y. Then sine of x minus y. Add up. And then you will be getting the required results. So all such results, they are available to us. Please move ahead. So again, such results, sine of x plus y is equal to 2 times sine of x plus y. So x and y are real numbers now. Or you can think of the radian measures of the angles. You can think of the radian measures of the angles, radian measures. So that is a type of situation. Then the sine 2x, I can write as sine x plus x. Then apply the formula, you can get the result. So on. So all these results are known to us. Then these are again two good results. You can cram, or for me it is very simple to bring out. Even try to note these two results. Generally, these two results are not there in an NCERT book, but the results are very simple. You can write the formula for cos x plus y. You can write the formula for cos of x minus y. Simplify. Just one line business. Just one line business will yield this result, sine square x, this cos square x minus sine square y. The sine of x plus y into sine of x minus y will give you this result, sine square x minus sine square y. Try to work it out. Working out is far better. You know the formula, apply it. Ultimately, in the process, you might have to use cos square x is equal to 1 minus sine square x, or sine square x is equal to 1 minus cos square x. So such results might be required to use. Of course, we have to use them. They are available to us. So such results, they are available. Then for sine 3x. So this result is also quite easy. If I want to bring out this result, I can apply this formula. That formula is sine of a plus b into sine of a minus b. I can apply this formula and then reach at this result. So sometimes, so this type of results, if you know them, our questions, they will be somewhat simplified. Otherwise, a little bit more labor. And in particular, note about these two, 3 final results. So here is, observe this result. It is simple to prove. This cos alpha, cos 2 alpha, double of that angle, cos of 4 alpha, cos of 8 alpha, so on, cos of 2 raised to power n minus alpha, double of that. So it is sine of 2 raised to power n alpha divided by, the proof is very simple. What I can do is, I can multiply by 2 and divide by 2. 2 sine alpha and cos alpha. 2 sine alpha and cos alpha. Then 2 sine alpha cos alpha will give you sine 2 alpha. Is it right? Try to understand it. Sine 2 alpha. Then again I can still divide by 2. Then the sine 2 alpha into cos 2 alpha will give you sine 4 alpha. Is it right? Again I can divide by 2. We'll be getting 8 alpha, like that. So if the final result will be 2 raised to power n. So such results, instead of proving again and again, we might apply them. Okay. So in your this competition exam, you should be aware of these results. Then this result, sine of alpha plus beta, and so on. So these real numbers, alpha plus beta, and so on, they form an AP. Alpha plus beta, then it is alpha plus 2 beta, and so on. So they form, this is the nth term. This is the nth term. And if a result is directly known to you, that well, it's good. Otherwise, I might have to calculate it. The calculation is not difficult. I can multiply numerator and denominator by 2 sine beta by 2. 2 sine beta by 2. Then here I will be applying a formula for 2 sine A sine B, like that. And getting this type of result. So try to remember these results. And these are some special values for the angle. Sine 18, cos 36. Are you aware of these results? Sine 18, cos 36. For me, it's very easy to prove, not really difficult. I love to prove these results. Instead of quoting these results, my approach is really to prove the results. Anyway, I quoted few results for you. So this is just a formulas. You will need these types of formulas. And if there is any trouble about any formula, so next time when you come, so if you want to give a proof of any result, well, the proof, I will be able to prove such results, any results out of these. But these are the few results which you will need for your competitive exam. Okay. So they are not difficult to remember, not to realize. So realize them. And then I am taking up the questions. Coming to the questions now. Please move to the third page. So here are a few questions. So more than 90% question, 95% questions I have taken from your Udan material, and I have taken few more questions They are again questions from only JE papers, few years back, maybe 2 years back, 3 years back. Few more questions I have added, only from UDAN, nothing else. So all these questions, more than 90%, they are from UDAN itself, what are material. So I have tried to think about that material properly, devoted enough time at my home, tried to select the material, that what type of material should be provided to the students instead of putting you just in here. I don't want to put you just in here. I want to put you on the solid ground, and from there you are to move ahead. So that is my approach of working. So I am working with you, working for you, working enough time. You may be working 3 hours, 4 hours. During last 6, 7 days, I have worked about 8 hours, 10 hours daily, and then brought up this material, selected material for you people. So that some meaningful uh, ideas, meaningful questions may be given to you. So here is your first question. This is a cotangent 15, cotangent 75. So what is this cotangent of 75? What is this cotangent of 75? Can you write it as cotangent of 90 minus 15? Is it right? 75. 75 I can write 90 minus 15. Is it right? So can I write it in the form of tangent? It's pi by 2 minus this. Tangent of pi by 2 minus this. So that will give you what? Tangent of 15. It will give you tangent of 15. Cotangent of pi by 2 minus x. Cotangent of pi by 2 minus x is equal to tangent of x. Is that right? So here is cotangent 75. That gives you tangent 15. So that your question becomes, what is the question now? So here is cotangent 15 and plus cotangent 75. That means tangent 15 and plus is cotangent 135. So what is cotangent of 135? You know its value? Is it minus 1 finally? Cotangent of 135. Is it minus 1? This is a 90 plus, you can take in that form. You can take 180 minus that form. It's all up to you. Its value will be minus 1. Is it right? So its value is minus 1. So here I am writing as minus 1. So minus 1 I am writing. Then this is a cosecant of 30. Cosecant 30 is 2. So that means minus 2. But here is this is to be simplified. The main situation is about this. So can I write it as cos 15 divided by sine 15 cotangent? This is tangent. So sine 15 divided by this cos of 15 minus 3. So can I write sine 15 cos 15 as LCM, sine 15 cos 15 as their LCM? So here I will be getting cos square 15 and plus sine square 15. So 1. I am saving one step. So here I will be getting cos square 15 plus sine square 15. Is it 1? So this 1 minus 3. And here is a sine 15 cos 15. Either we should write their values of sine 15 cos 15, or better will be to write it as 2 over. So it is 2 sine 15 cos 15. Sine 15 cos 15 minus 3. Is it a formula? 2 sine A cos B. Sine 2A. So this becomes simple. So here it is. This is equal to 2 over sine of 30. So can you write the value of sine 30? 1 by 2. I am saving a step. So it is really sine 30, and sine 30 is 1 by 2. So minus 3. So this 2 goes up, 4 minus 3. So 1 is the answer. So that is your correct choice. It's 1. Is it right? So here is your next question. So what is the sine 47? So here is a sine of 47 plus sine of 61. I am collecting these two, then minus. I am getting as a sine of 11 and sine of 25. These two terms being collected, these two terms collected. So here, you know the formula is what is sine C plus sine D, or what is sine of X plus sine Y? 2, yes, 2 sine of 47 plus 61. Divide by 2, what is that? 47 plus 61. Yes? 54. Is it right? Into cos of. What is that cos of? 47 minus 61 minus 14. Divide by 2. Minus 7. Is it right? 47 minus 61 is 14. Divide by 2. 7 minus 7. Cos of minus 7. So cos of minus 7. And here is minus sine of, what is that? Sine of 18. Sine of 18, and into we are getting as cos twice sine of 18 into cos of minus 7. Now here it is 2, and cos of minus 7. What is cos of minus 7? Cos of 7. So here is 2 cos of 7 I am taking out. And then inside we are left with sine of 54. Sine of 54. Can I write as cos of 36? Sine of 54. Sine of 54 can be written as sine of 90 minus 36. 90 minus 36. Is it right? Can I write cos of 36? So here is cos of 36. Cos of 36 and minus sine of 18. Is it clear? Or cramming? Clear? So now here is cos 36, sine 36. The results were there with you. I've given you the results directly. Cos 36, sine 36. Sine of 18. So what was cos 36? You know it? You don't know it. You don't remember it. Well, if you are to appear in the competition, you have to remember it. Root 5 by 4, and then here is minus root 5 minus 1 by 4. So what will cancel out? The term containing root 5 will cancel out. Is it right? Plus, minus. So this term will cancel out, and here will be left with 1 by 4 minus this again 1 by 4. 1 by 4 and 1 by 4 is 1 by 2. Is it right? 1 by 4 plus 1 by 4 is 2. So finally it is 2 into cos of 7 and into 1 by 2. So 1 by 2 cancels out cos of 7. So here is your cos of 7. So you have to move the situation like this. Then I am providing some hints. So collect these two terms, apply the formulae. But what is cos of 156? Cos of 156. Can you write minus cos of 24? Cos of 156 is minus cos of 24. Is it right? 180 minus 24. 180 minus 24. And cos of 180 minus 24. Second quadrant, negative sign. So minus cos of 24. Is it right? And here it is cos of minus 48. So just a hint to that. So remaining I will leave for you. So the first two term I am not writing. So anyway, so here is cos of 12 and then cos of 84. And the next I am writing minus. So here is cos of 24 and cos of 48. Is it right? Collect these two, then collect these two. Apply the formulas. You know the formulas? So twice cos of x, this cos x plus cos y. What is cos x plus cos y? 2 cos of x plus y by 2 into cos of x minus y by 2. Apply these formulas. And ultimately you might have to use cos 36, sine 18, like that, such value if needed. If they are available with you, use them and get the answers. So here collect these two terms. So sine C minus sine D. You know the formulas? And then collect these terms. Collect these terms. Again apply the formulas. So you'll get the answers. Then here's your next question. Here, this is, I am just providing you the hints. Here is a tangent 81. What is tangent of 81? Tangent 81. Is it cotangent 9? Tangent of 81 is cotangent 9. Is it right? Tangent of 81 is cotangent of 9. So here is cotangent of 9. Cotangent of 9, then tangent of 9. Collect these two terms together. Cotangent 9, tangent 9. Then here is 63. What is 63? Can you convert it in the form of 27? So cot of 27. So here is a cotangent 9 plus tangent 9. Club them together. And then here is cotangent of 27, tangent of 27, 9 minus negative sign outside. Then club these together. And you have already learned the way of simplifying sine by cos, cos by sine. You learned that way of simplifying. Simplify it and get the answer. Is it right? Are you learning or cramming? You are learning. So that is the way to learn. So here we are here to learn this. Now here is a sine of 54. What is sine of 54? Cos 36, right? You are coming up now. So that is a way to learn. We are learning. So sine of 54 is a cos of 36. And the value of cos 36 is known, well known. Is it right? And then here you need 2. We can multiply and divide by 2. You can multiply and divide by 2. So it is 2 sine A sine B. 2 sine A sine B. Or 2 sine X into sine Y. You know the formula? What is 2 sine A sine B? 2 sine A sine B? Yes. 2 sine A sine B? Or 2? Yeah. Cos their difference minus cos their sum. Yes. Yes. Cos their difference minus cos their sum. You have forgotten those formulas? So try to learn them. Cramming comes later, much later. First is to understand. The first is to understand. Then, of course, a little bit cramming. Provided we understand, then cramming also becomes simple. Otherwise, cramming creates problem. And if whenever there is a problem, if you think that I may be wrong, then why not to simplify that? Cos of x minus y and cos of x plus y. Apply that formula is known. This formula is known. Simplify it. And you see whether you reach at the proper place or not. You reach at the proper place, that means you are right. If you don't remember, so if there is a problem like this, sometimes there is a problem like that. Even with me, that problem may be there, does not matter. But one can realize it. One can simplify it. And if simplify it, one reaches that result. If there is any trouble of negative sign or so on, one can see which term is to be written first, which is to be written later. So that is a way to learn. So this is how we can think about these formulas. Then here is question number 7. I'm providing some hints to few questions. So here is this question. What is to be done? Here is question 7. So here we have got cos of last term. Look upon the last term. Cos of 7 pi by 8. Cos of 7 pi by 8. Can I write it as cos of pi minus pi by 8? 7 pi by 8. Can I write like this? What is this? Is it minus cos of pi by 8? Cos of pi minus this pi by 8 is cos of pi minus x is equal to minus cos x. Is that right? And the same is the situation about cos of 5 pi by 8. look upon this cos of 5 pi by 8. Cos of 5 pi by 8, we can write it as cos of pi minus 3 pi by 8. And this will give you cos of minus cos of 3 pi by 8. So now in total, what you can write? Cos of pi by 8 into this term I can write first. So we'll be getting, now look upon your left hand side or that expression, given expression. So what is that given expression is equal to? So 1 plus cos of pi by 8. Can I write this term earlier? So in place of writing this term, 1 plus, can I write 1 minus cos of pi by 8? I can write 1 minus cos of pi by 8. And I am writing here at this place, 1 minus cos of pi by 8. And into I am writing 1 plus cos of 3 pi by 8 into what? What should I write? Into 1 minus cos of 3 pi by 8. What is the advantage of writing like this? It gives you 1 plus cos A into 1 minus cos A. So 1 minus cos square. 1 minus cos square. So here is 1 minus cos square pi by 8. Cos square pi by 8 into 1 minus cos square 3 pi by 8. And what is 1 minus cos square x? Sine square x. So here is sine square. We can convert it in sine square pi by 8. And then this is sine square 3 pi by 8. After this, one more manipulation is required. So another step to be noticed is, so here is sine of 3 pi by 8. I am writing it as sine of pi by 2 minus pi by 8. What is this? Check it. What is this number? Pi by 2 minus what is this? Pi by 2 minus pi by 8. Are we getting 3 pi by 8? Check it. Pi by 2 minus pi by 8. What is the LCM? 8. So we'll be getting 4 minus 1, 3. So 3 pi by 8. Is it right? And this I can write it as cos of pi by 8. I can write it as cos of pi by 8. Is it right? So what is the advantage of writing like this? So this becomes now sine square pi by 8 and into cos square pi by 8. Sine square pi by 8, cos square pi by 8. And what should be our next step? Multiply and divide. 2 or 4. 4. So multiply it and divide by 4. And that 4 I am writing as sine of pi by 8, cos of pi by 8 whole square. So this is further equal to 1 by 4 into sine square pi by 4. And I have brought it finally in a proper shape. So what is sine of pi by 4? 1 minus root 2, or only 1 by root 2. 1 by root 2 whole square. 1 by root 2 whole square. So 1 by 4 is 1 by root 2 whole square. So is it 1 by 8? So what is our answer finally? What was there, question number 7? 1 by 8. That was the answer to this problem. Can you bring the question number 16? A similar question, let me point out, maybe on the next page. I'll look upon this question. So here is cos of 7 pi by 8. Here is cos of 5 pi by 8. Cos of 7 pi by 8, what was that? What was cos of 7 pi by 8? It was minus. So cos of 7 pi by 8, cos of 7 pi by 8, that was equal to minus cos of pi by 8. And what was cos of 3 pi by 8. That was equal to cos of 5 pi by 8. That was minus cos of 3 pi by 8. Is it right? So this as a whole now, this expression will become what? In place of this, I will be writing minus cos of 3 pi by 8. And the powers are 4. 4 powers will make it positive. All right? So this term and this term, they will be the same. This term and this term will be same. And this term will be equal to this term. So that means the given expression will become what? So given expression will finally become twice of cos of pi by 8 power 4 and plus cos of 3 pi by 8 power 4. And what was cos of 3 pi by 8? Can we manipulate it in that form? As there we manipulated. So here we can manipulate it in that form. So look upon this cos of 3 pi by 8. Can I write it as cos of pi by 2 and minus pi by 8? Is it right? And what is this? Sine of pi by 8. So this becomes sine of pi by 8. Are we not much comfortable if we write here as sine of pi by 8? We write here as sine of pi by 8. So see what is happening. So this will further give you that was the result 2 cos of pi by 8 power 4. And here we are getting sine of pi by 8 power 4. So here is cos square x, cos power 4 rather, cos x power 4 and plus sine x power 4. Can you think of how it should be written? Right, cos square x plus sine square x whole square and minus twice of that. So here it is twice of, I am writing as cos square pi by 8 and plus a sine square pi by 8 whole square and minus twice of what? Minus twice of cos square pi by 8 and sine square pi by 8. Is it right? And so this is further equal to twice. What is this? 1. Good enough. So minus. What to be done? I need only 2. And then it will become a square. The same situation. Is it right? It's resembling the same problem, coming to the same problem. So here we are getting as 1 by 2, I am writing extra. Then I will be getting 2 cos of pi by 8. And here it is sine of pi by 8. And this is whole square. Is it clear that how the things are happening? So this is equal to 2. And here it is 1 and minus 1 by 2. And this will give you what? Sine pi by 4. And sine pi by 4 is 1 by root 2 and a whole square. So it is a 1 by root 2 and whole square, 1 by root 2 and whole square. So that gives us what? That gives us 2 into 1 minus 1 by 4. Is it right? So this is equal to 2 into 3 by 4. So what is the final answer? 3 by 2. So here is the final answer, 3 by 2. So if you have done that question, so this question can be thought of by you itself. If that question was there with you, then we can realize that how the manipulation goes. Some calculations, they are required to be done. So we can go through the calculations. So bring that previous page back. So this question is from your Udan, This question is from your previous IIT papers. This question is again from your previous IIT papers. This question is from Udan. I want to take up one question out of these three. All right, the first question is very simple. Eighth one. X is equal to y into cos of 2 pi by 3. What is cos of 2 pi by 3? Minus 1 by 2. Good one. So this x is equal to minus y by 2. Is it right? And what is this cos of 4 pi by 3? Cos of 4 pi by 3 is cos of pi and plus pi by 3. So that goes in the third quadrant. But cos remains cos. And in the third quadrant, again, it is negative. So it is again minus 1 by 2. So this is equal to minus 1 by 2. Z by 2, that means. Z by 2. Find out the value. Cos of 2 pi by 3 is minus 1 by 2. Cos of 4 pi by 3 is also minus 1 by 2. Let me call this, say, as lambda or k, whatever you want to say. I am calling it say as lambda. So what is this x? X is equal to lambda. What is y? Y is equal to minus 2 lambda. What is z? Z is equal to minus 2 lambda. Thank you very much. So now what you need? We need the value of x, y, y, z, z, x. Very simple. Nothing much is required. So I need the value of x, y plus y, z plus z, x. So what is x? X is equal to lambda. What is y? Is minus 2 lambda. Then this is as minus 2 lambda into minus 2 lambda. And then this z is minus 2 lambda into lambda. So what is this finally? Minus 2 lambda square. And here is 4 lambda square. And this is minus 2 lambda square. Is it 0? That is what we need. The value of this x, y plus y, z plus z, x, that was 0. And this is a question from your Udan. So here it is x by cos of theta is equal to y over cos of theta minus 2 pi by 3. Here is 2 pi by theta minus 2 pi by 3. Can I write cos of minus theta is equal to cos of theta? Cos of minus theta can be written as cos theta. So if I take a negative sign out in that way, so this can be converted to cos of 2 pi by 3 minus theta. Is it right? Because we know that cos of minus theta is equal to cos of theta. So if we use that, so this can be converted to that. Anyway, here is z over. So the next is cos of theta plus 2 pi by 3. I want to write it in a simple manner. I want to convert it as x by cos theta. And here I want to write y as cos of 2 pi by 3 minus theta. And here it is cos z over. So it is cos of 2 pi by 3 I want to write earlier. Does not matter. Is it all right? So I am calling it, say, lambda or k, whatever you want to say as k. Let me call it as k. I will be getting the value of x. X is equal to k into cos theta. Y is equal to k into whatever is there, z. And he needs the value of what? He needs the value of x plus y plus z. The solution given in Udan is, I think, foolish way of writing the solution. That is not the way of writing. He is writing, putting 0 in the denominator. I think, what else word I can use? That's enough. Just a foolish way of writing the solution. So here it is x plus y plus z is equal to what it should be, k into cos theta. Here also k into cos theta is k into cos theta. So k I am taking as common. So here I am writing as cos of theta, then cos of 2 pi 2 pi by 3 minus theta, then it is cos of 2 pi by 3 plus theta. Is this step clear? And then some simplification. I think better to simplify here. What is cos of x plus cos of y? Cos x plus cos y. 2 cos of x plus y by 2 into cos of x minus y by 2. Please apply this formula. So on applying this formula, so what will be getting k into cos of theta and plus, so what I will be getting twice cos of a plus b by 2. A, this plus this. Theta will cancel out. 2 pi by 3 plus 2 pi by 3 by 2. 2 pi by 3 plus 2 pi by 3 by 2. So we'll be getting 2 pi by 3. And then this cos of this minus this. So what it will be? 2 pi by 3 will cancel out. Minus theta, then minus theta. So minus 2 theta divided by 2. Cos of minus theta. And cos theta, good enough. Cos of minus theta, we'll be getting cos of minus theta. But we know it, that cos of minus theta is equal to cos of theta. After all, we are to appear in the competitive exam. Such steps must go orally. They must go orally. So we'll be getting cos of theta. And what is this cos of 2 pi by 3? Minus 1 by 2. So what is this minus 1 by 2? With this term and this term finally cancel out. I write 1 by 2, minus 1 by 2 at this place. I write minus 1 by 2. So here, anyway, you want to write me a step. And so here it is 2 into minus 1 by 2 and into cos theta. So is it 0 finally? Minus cos theta. So this is 0. That's what he is expecting. He was expecting us from this very result. So this is the best question out of these three. So here it is x into cos alpha is equal to y into this is equal to z into this. Then the value of x, y plus yz plus zx, its value is needed. So that is the best question out of these three questions. Of course, they were of the similar nature. Anyway, I don't have that material with me. Well, I might try this question, whatever it is. But whatever material I am going to provide you on this is Udan, I think tomorrow that material will be loaded. So best will be, I have selected the best material out of this Udan. So for you, I would advise that first of all, you go through that material. And tomorrow, we'll be providing you the solutions also. Again, that will be available on your tablets. So go through those solutions and go through the material. I have selected some material. A quite good number of questions have been selected. So for you, so to go through that material. Anyway, here is a, no. So here is a question on a triangle. So I have not taken up the questions on triangle. So whenever I will be taking up the questions on triangle. So really what I have been given is two topics I have been allotted. That is the trigonometric functions, then trigonometric equations. I have been asked to give these two topics. And there is one thing more left about this, that is the questions on a triangle. Questions on a triangle. So here is a question on triangles. So question on triangle is not given to me as yet. Anyway, if it is I am asked to do that, so I will request for another period, another session, and then I will be taking up the questions on this triangle. Haphazardly, I don't want to try this question. Anyway, it is available, of course. I can do it, but I want to give some proper background. So if first a proper background is given, and then to try the question, that is far better. So again, these questions they are asking on a triangle, and most of these questions, 90% questions, they are from S.L. Loney's book. 90% this material, they are from S.L. Loney's book, so about 100 years back. But still, some questions, they are to be prepared. I am not totally ruling out all these questions, because some questions may be asked, but I have not been asked to today work on that. So today I will be taking up the questions on, in particular, questions on trigonometric functions. Trigonometric functions, they are your next 4 lectures here from page 300. These today I am taking up the topic from, this is from page 300 to, I am taking up the topics from 300 to page 339. It's about a 40-page material. I think more than enough material I am trying to cover. And so from page 300 to 339. And I have selected enough number of questions from this material. And today, whatever I have put up the questions, the best questions, whatever I think, I am trying to provide to you. So these questions, if I am asked next time, I will be providing these questions. So only these 2 questions have been asked? Yes. Anyway, so I can continue another half an hour if they are prepared to work. And if you are prepared to work, 10 minutes, only 10 minutes. Okay, then bring up the next. So here is again a question from Udan. So the sign of y plus z minus x, all these 3, they are in AP. They are in AP. When we are talking about AP, we are talking about real numbers. That is a type of situation. So, and then he is asking about tangent x, tangent y, tangent z. They are in AP. So we think that is just confuse. Don't confuse the situations. So we are working on these. We are given that they are in AP. What is the definition of AP? You understand? This minus this must be equal to this minus this. That's what is the meaning. So meaning of AP, I am trying to interpret. So we are, here is through this question number 11. So we are given sign of y plus z minus x, and then sign of z plus x minus y, then sign of x plus y minus z. So these numbers are given to be in AP. If they are in AP, that means the sign of z plus x minus y minus this term, sign of y plus z minus x is equal to sign of x plus y minus z and minus this term, so minus sign of z plus x minus y. Is it right? That is the definition of AP. Now, what is the formula for this? Sin C minus sin D, or sin of x minus sin y. What is that? Sin C minus sin D. 2, yes, twice cos of 2 into sine of C minus D by 2. Is it right? So that is the formula. We need this formula. So this is equal to twice of cos of their sum. What is their sum? This x will cancel out and y will also cancel out. So 2z by 2. 2z by 2. So that means cos of z. And then we'll be getting sine of this minus this. This minus this. And here z will cancel out. Z will cancel out. So here is x and this minus x. That means 2x. And then minus 2y. 2x minus 2y. Divide by 2. So it will give you sine of x minus y. Is it clear or not? We're using that formula. Twice cos of c plus d by 2 and into cos of c minus d by 2. But somehow or other, in my mind, I don't want to say c and d. If I think about c and d, I may not be confusing with the angles. So it is really better to remember them in the form of real numbers. So try to remember them in the form of real numbers, sine x plus sine y, sine x minus sine y. And here it is sine x minus sine y. So it is twice cos of x plus y by 2 into sine of x minus y by 2. So this is equal to twice of cos. Cos their sum. So what is the sum? So which numbers will cancel out? Z will cancel out. Y will also cancel out. We'll be left with x. So twice cos of x. And then sine of, we'll be left with y minus z. Check it. Apply that formula. So we are left with this much. Can I cancel out this 2 from both sides? So 2 has been cancelled out. So here is cos of z. Now here is sine x minus sine y. What is the formula for this? Yes, sine x cos y minus cos x sine y. Cos x sine y. And on the other side, here it is cos of x into sine y cos z minus cos y sine z. So can I divide both sides by cos x, cos y, cos z? Dividing both sides by cos x, cos y, cos z. Divide both sides by cos x, cos y, cos z. So cos z we are dividing here, and then we'll be getting as we are dividing by cos x. We are dividing by what? We are dividing by cos x, cos y, cos z. Cos z will cancel out. And here we are dividing by cos x. So can I write tangent of x? Here I will be getting as tangent of x. Is it right? Cos y will go on division. I will be left with only this tangent of x. Is it right or not? And so I am dividing by cos x, cos y, cos z. So cos z cancels out. And here we are dividing in the remaining term by cos x, cos y. Cos y cancels out. So we are left with tangent. And here we are left with what? We are left with tangent of y. And on the other side, cos x goes. And we are left with what? Tangent y. We are left with tangent y. And then minus, we are left with tangent of z. We are tangent of z. That's what we are left with. Can I write this as, so here is tangent of x plus tangent of z on this side is equal to, this term goes to the other side, 2 tangent of y. From here, can I say that tangent x, tangent y, tangent z are in AP? Tangent x, tangent y, tangent z are in AP. That is the definition of AP. So from here, justified to say that this tangent x, tangent y, tangent z are in AP. That was the problem. Whether they are AP, GP, HP, none of these, that was the situation. Question number 12 is a nice question, good question, very good question. I think enough time to go through one more question. Anyway, 2-3 minutes more, it will go on. So let us take up this question. So here's x1, x2, x3, and xn. They are in AP. Given to be in AP, and common difference is alpha. Common difference is alpha. What does it mean? All these numbers are in AP, and common difference is alpha. Now this x2 minus x1. x2 minus x1. Will this be alpha? What will be x3 minus x2? Will it be alpha? And so on. So this will be xn minus 1, and each will be equal to alpha. x2 minus x1, x3 minus x2, because all these numbers are given to be in AP, x1, x2, x3, so are in AP, x2 minus x1, that is here their common difference, is given to be alpha. x3 minus x2, common difference, alpha, and so on. Now here we need the value of sine of alpha into this expression. So here is your given expression. Look upon the given expression. So what is that given expression? So given expression is equal to, it is sine of alpha. So here it is sine of alpha, and into what is given? Whole into sine of alpha into secant x1, secant x2. Can I write this as 1 by cos of x1, cos of x2, 1 over cos x1, cos of x2. I am writing it as cos of x2, cos of x3, and so on. I am writing it as 1 over cos of xn minus 1, cos of xn. Secant, it is secant of x1, secant of x2. I just written as 1 by cos of x1, 1 by cos of x2. That's what I have done. So this is equal to, can I multiply by sine of alpha? Multiplying by sine of alpha, but alpha is equal to x2 minus x1. So here is the manipulation, sine of x2 minus x1. So I am writing sine of alpha, multiplying by sine of alpha. But what is alpha? Alpha is x2 minus x1. So divided by is cos of x1, cos of x2. And plus, so here it is sine of alpha. But below we are getting x2 and x3. I should write it in this form, x3 minus x2. So here it is sine of x3 minus x2 divided by cos of x2, x3. Are you getting this step? So we are multiplying by sine of alpha divided by this, sine alpha divided by this. But here alpha, that alpha is being written in the form of x1 and x2. And here we are going to write alpha as in the form x2, x3. That is the way. This is how we can simplify this expression, and so on. So here I can write sine of xn minus 1 divided by cos of xn minus 1 into cos of xn. Is this step clear? That is the main step in the problem. Now, here, what can be written? The formula, sine of x2, cos of x1, minus cos of x2, sine x1. Can you divide and save one step? So here I will be getting as sine of x2, cos of x1, minus I will be getting as cos of x2, sine of x1, and divided by cos of x1, cos of x2, and so on. All these terms, of course, they are to be written. But can you simplify it? So this will give you what? Tangent of x2. So and minus tangent of x1. So first bracket gives you this one. Tangent of x2 minus tangent of x1. Is it right? So second bracket is going to give you tangent of x3 minus tangent of x2. And so on. So what is going to give you the last bracket? Last bracket is going to give you xn minus tangent of xn minus 1. It's going to be up. Just 1 minute. So what terms will cancel out? This term, these terms will cancel out. Right? The tangent of x3 will cancel out. So on. So finally we'll be left with what terms? We'll be left with only that positive term, tangent of xn and minus tangent of x1. So we'll be left with only this term. So convert, only this much will be left. Is it right? So convert it as sine by cos, and then simplify it. So again, we'll be getting some formulae. So finally, you'll be reaching the required result. It's a very good question. Just 1 or 2 steps more. Should not be difficult for you to write. This should be tangent of xn, that means sine of xn divided by cos of xn, minus, that is sine of x1 over cos of x1. Take up the LCM, simplify it. In the numerator, you'll be getting a formula. You'll reach the required result. So thank you very much. Thank you all the students who are online. I think you must have enjoyed, learned a little bit of trigonometry and the real shape of trigonometry. Not only trigonometry, the real shape